All right. Hi and welcome to my presentation or the code screencast in the course Advanced Web Programming. My name is Jacob and my project is a web application for backtesting stock strategies in the Nordic stock markets. And just to relate back to the previous video where I demonstrated the application, the backtest that we started in that video have now finished. So as we can see, this is the value strategy. And the status here has changed now to successfully finished. And we can also see the different statistics for the strategy. So as we can see, this strategy performed quite well during this period and gave a hypothetical return of about 95.66%. And this was backtested in the period 2016 to 2020. So I just wanted to mention that, and with that out of the way, we can jump into the code. So my project is built with Angular on the front end and Node+Express on the back end, and then I have a separate task server with a simple fast API, a Python API. So the general structure looks like this. The backtester directory contains all of the Python code for the custom implementation of the backtester. And I thought I would make a separate video about this one since it would take too long to explain everything in one video. The client directory contains all of the Angular code for the front end, and the server directory contains all of the Node+Express code. So let's start with looking at the client. So in the client directory, we can see first off a lot of different JSON files, etc. here, and this is a lot of boilerplate stuff that are generated when you generate a new Angular application. So I won't go into detail on all of these different configuration files. But the main code or the code base is in source app here. And I've divided the Angular structure into a couple of different modules. So we have the core module, which contains logic that are core to the entire application. So this would be the footer and the header of the application, as well as the different services. So I'll go into detail more later on what services are. Then we have the modules section here, and this contains pure Angular modules. And this is basically grouped together components that are related to each other. So authentication components are grouped together in this directory. Then we have another module for all of the backtester related components and so forth. And in shared, we have all things that are common to the application that can be reused, such as all of the TypeScript models. So if you look at the user model, for example, this is a TypeScript model that defines how a user looks in my system. In similar fashion, we have type definitions for the backtester. For example, how it expects a strategy to look. So a strategy has to contain metadata, which is of type strategy metadata, and that is also defined here, how that looks. So I have a bunch of different types defined, so everything is built on TypeScript basically, with type definitions. Right, so let's look at some specific code for some services and components. So if you look at the core services section again, this contains all of the different services here, and what this is basically a way of delegating away functionality that doesn't have to do with the presentation layer of a component. So instead you can delegate it away from the component logic and in the same at the same time and make it reusable, since you can inject these services into multiple different components and reuse that functionality. So one example that I wanted to show you is the auth_guard service. So what these does is they are used with the routing to protect routes based on different conditions. So the first one, the auth_guard service, checks if the user is authenticated, and if the user is authenticated, it will let the user visit that particular page or route. And in a pretty much reverse fashion, the logged in guard service checks if the user is already logged in, and if they are logged in, it will deny access to this particular route. So to relate this to where they are actually used in the code, we would have to check out the app routing module. So here is where all of the different routes of the application is defined. And we can see that the different routes are specified as a path and a component. And all of the different components here are Angular components. And I've used the naming convention page here to define that this is an actual page that wraps a bunch of other components. We can also see that we have specified this can activate here. And here we can make use of the different guard services that we have set up. So for example, the register and login page cannot be viewed if you're already logged in, and the other routes can only be viewed if you've already authenticated yourself and logged in. Right, so that was the auth guard service. Then we can check out the auth service. So this is a service containing all of the methods that you would need to use to authenticate a user and perhaps create a new user or log out of the system. And the methods here pretty much all make HTTP requests against the backend to perform some form of task, such as registering a new user like this one here. And we can see that here we also have type annotations. So we can see that we are expecting to get in register information, so data of this particular type, and what we return is an observable of the user type, basically. And this is a way to leverage RxJS observables to handle asynchronous events. So when we return an observable from this method, we will then subscribe to it with a callback function. So these are called observer functions. And then when we actually have gotten back the data from our backend, our Node API backend, then that callback function will be called. And then we can do whatever we want with the actual data inside of those functions. So I will show you how that looks in the TypeScript code of a component later on. And in a similar fashion, we have methods for logging in and logging out, and these also make HTTP requests against the backend. We have a bunch of these different services, and they all have their own little area of tasks. For example, the backtester related tasks goes into the backtester service and so forth. But most of it looks the same in that it pretty much all relies on HTTP requests against the Node+Express API, and then returns an observable of some type. Right, so let's look at some components. So if we go into the module section and the auth section, we can see that each module has a directory called components, which contains smaller components, and then we have pages, which contains the components that act as the actual page wrapping the other components. So here we have the login page as well as the register page. If we check out the login page, we can see that this Angular component contains 4 files. So when you create a component through the Angular CLI, it usually generates 4 different files: an HTML file, as well as an SCSS file. In this case, I don't have any styles for this particular component, a test file, as well as a TypeScript file. And in the TypeScript file, you can define all of the component related logic and define methods and functions and so forth. Right, so in this case, we can see that the component is built up of mat card, which is a Angular material component from the Angular material library of components that I've used in the project. And here we can also see app login form, which is a custom Angular component. So if we want to check out that one, it is defined in components here. Then we can check out login form. And this is also built up of a bunch of different Angular material components, such as mat form field, mat label, and so forth. Right, so if we check out the TypeScript file here we will see how the actual logic of calling a service works. So we can see that we have injected the authentication service here inside of the constructor of our component, so the login form component. Then we can make use of this service and call the login method in this case. So remember that this will return an observable of type user. So then we can subscribe to this with our observer function, which is a callback function. And when this is called later on, it will then get the actual user as a parameter. And then we can do whatever we want with that user object. So in this case, we have a successful login, and then we will re-navigate to the backtester view. In the case of errors, we can also specify a callback function that handles the errors. And that is what we've done here. Right, so that was this component. Another component that I wanted to show you quickly is inside of backtester. So the backtester is the biggest module, and it contains a bunch of different components here. One component that was a bit of a challenge to get to work was the filter component. So if we check that out a bit, we can perhaps relate it a bit to the actual application as well. So if we check out the backtester, we can see that we can add pretty much an infinite amount of different filters in a pipeline order like this. And the list of filters is built up by this filter list component. This is also a good way to demonstrate the different Angular directives in use. So here we can see the structure of the filter list component, and you will see some special syntax like this ng4 directive here. So this is an Angular directive that can be used to add additional features or behaviors to your components or HTML elements. So in this case, we want to create a filter. So one of these filter components for each filter in the array called filters. So inside of this component, we have a specified array of numbers here, which is called filters, and it's those that we are looping over to create these individual filter components. Anyway, the actual challenge with the filter was that getting the actual formula validation to work properly and only allow you to specify a given set of KPIs that the system recognizes. So for example, if you just type in some random stuff, you should get a formula error in this case. And I managed to solve this by borrowing a bunch of logic from the Math.js package and repurposing that for my use case. So in the filters, on initialization of the filter component, I will go through the list of KPIs that I allow the user to make use of in the system, and I will build up a scope of these KPIs. So scope is a concept of Math.js where you can provide your Math.js instance with a scope of constants. So I actually set the different KPI abbreviations as constants in this scope. And in that way, I can use the Math.js evaluation and check if it's a valid formula based on those constants that I've also defined. And this all happens in this custom validator function called formula validator. And what we do is we try to evaluate the formula with that scope that we have also created, consisting of those KPIs as constants. So if this evaluates to a value that isn't nan, so not a number, then we know that it's a valid formula, and we can we can let it pass. Otherwise, we return a specific formula error that we then can use in the validation part of the presentation layer here. Right. Yeah, I guess we'll move on to the back end of things now, because time is quickly racking up. But that was a bit of an introduction to the different components, but there's a lot to cover, so can't go through everything. Right, so let's close this down and then check out the Node+Express server. So in the same way here, we have some configuration files that we don't really have to look at. They are more related to getting hot reloading to work and managing all of the different packages and so forth. But in the source directory here, we have all of the code related to the backend. And it's also divided up into not really modules in this sense, but I've tried to structure the code. So all of the different routers go into this routers directory. Models, so this is basically the same as in the Angular code base. We have TypeScript definitions here as well, so we use TypeScript on the server as well. And then we have some static data for KPIs. The trading dates is not really used anymore. But I wanted to show you the authentication part. So in the auth part of the backend, we leverage the passport middleware. So this allows you to implement a login and register system in a very convenient fashion. So in the passport config here, we basically initialize passport, and we also create some functions for authenticating a user as well as serializing and deserializing a user. And these come in handy in order to append the user, the currently logged in user, on a request automatically, so you don't have to do a bunch of work with querying for the sessions and so forth. All of that will happen automatically. And in this case, we in the authenticate user function here, we also leverage a static mongoose method that we have provided on the user mongoose model. So this basically checks if there exists a user already with a particular username and password, so if it's a valid user that you're trying to log in with. Then we have the auth routes as well, so this defines different register, login and logout routes. So when we looked at the authentication service in the Angular frontend before, we saw that it made HTTP requests against the server, and it's one of these requests, or rather one of these routes defined here, that it would request then, for example, register. And this this will first leverage another custom static mongoose method, user exists, which checks if a user already exists or an email or username is taken. If it's already taken, yeah, you can't register that user. Otherwise, it will let you save that user to the MongoDB database, and it will return the new user that you've created. We also have some custom authentication middleware. This check authenticated is something that you can use in your routes, and only allow the route to be accessed if the user is logged in. So I can also show you a quick example of where that is used. If we check out one of the other routers, such as the backtester, we have a route for running backtests, which is called backtester/run here. Here we can see that we specified this custom middleware check authenticated. So that will first check if the user is logged in and authenticated correctly using cookie-based sessions. And if the user is authenticated, it will allow the user to start the actual backtest. And yeah, the backtest leverages this other method over here to make a request against the fast API backtester that is exists over here. Right. What else? So we have a bunch of routes for the different areas of the application, such as the users here. The users router contains all of the routes for following and unfollowing a user. So this basically is a bunch of Mongoose queries for finding out if a user is already following or not following the other user, and then updating the user document in the user collection that corresponds to both the actual user that tries to follow another user, and then also the user that is being followed, since we track both things for each user. So an example here would be this type of Mongoose query, where we check if the user's following array does not contain an element that is matching the particular ID where we're trying to follow, then we will add that particular ID to the following array. So Mongoose makes it quite convenient to do these types of operations, but you have to first look into the different queries that you're actually allowed to do. Right. So other than that, most routes follow the same pattern. Basically checking if the user is authenticated, and then doing a bunch of Mongoose queries of some sort. So I don't think we have too much stuff to go through. We can maybe wrap up with this one here. So the actual backtester route here will, as I said previously, make a request against the fast API. So the route for running a backtest on the actual Python backtester. And I've wrapped everything in a promise here, so we can run this asynchronously. So the actual route that the actual express route that starts the backtest will respond to the front end pretty much immediately. So the backtester will start to run asynchronously, and you won't it won't sit and wait for the actual backtest to run, since the backtest can take quite a while to perform. Sometimes maybe an hour even, depending on how long back in time you go and how much, or rather how large your universal stocks is in the backtest. So that happens asynchronously, and currently I haven't really set it up to be able to refresh when the actual backtest has finished. So you have to reload or refresh the web application for it to actually update when the backtest has finished. And I didn't really see any point in implementing anything with sockets or that kind of implementation here, since it takes such a long time for the backtest to run. So you wouldn't really have a lot of interactive or interesting stuff happening that you would want to stream to the front end. But anyway, this pretty much sums up most of the web related stuff in this application. I will make a separate video on the backtester, since that might be interesting to someone as well, but this is perhaps not as related to the web programming side of things. I can show you the fast API, which is super simple. So I only have one route set up here, the backtester route, and this is used to start the actual backtest, and this is the one that's called from the backtester/run route defined in the backtester router here. And a takeaway from this project is also that fast API is really convenient to work with, super fast at reloading, so it's great for developing. And I also think it's really convenient in how you define routes like this. So first you use a decorator like this to specify what type of request it is. So in this case it's post. You define the route, and then just a function. And I'm using Pydantic here to also have strong typing on the Python side of things. And pretty convenient. Then you just return it like this. Instead of doing some form of response.send.status, you can just return and it will work out of the box. So yes, I think I'll wrap it up here. Thank you for watching, and if you're interested more in the details of the backtester logic, check out the other video as well. Thank you for watching, and goodbye.